Hi, my name is Jonathan Bergsogel, and I'm a software architect working on TI's automotive infotainment processors. I'm here to demonstrate a few of the features of TI's robust rearview camera solution for infotainment system designs based on TI's Jacinto 6 family of infotainment processors. The robust rearview camera solution that is running here on a Jacinto 6 DRA74X processor supports a fast start of the rearview camera video within 2 seconds after power on of the system. The solution also provides important protections against possible malfunction conditions and high load situations in the infotainment system. As you can see, the rear-view camera video is already displayed in the foreground of the LCD screen, while the Android operating system, here in the background, is still in the process of booting up to the home screen. I can press a button here on the side of the board to simulate shifting the car from reverse gear back to drive, and then the rear-view camera overlay on the screen goes away. Now I can simulate shifting the car back into reverse again. The fast start of the rearview camera video is accomplished by loading a firmware image to a set of auxiliary dual ARM Cortex-M4 cores shortly after power on of the infotainment processor and running this ARM Cortex-M4 code image before the main infotainment operating system, in this case the Android OS, starts to boot on the ARM Cortex-A15 cores. The next feature I want to show you is the frozen camera frames detection and handling accomplished in our rear view camera solution. We use a series of camera frame CRC checks in order to detect frozen or missing camera frames that are normally expected to be updating in a regular fashion. For example, when I simulate cutting the camera sensor connection by unplugging the camera cable from the board, you will see that the code on the ARM Cortex-M4 cores detects that the input frames are all the same and a warning message is displayed on the screen. Next, I would like to show you the peripheral register monitoring feature of our robust solution for detecting any potential configuration changes in our display controller that could accidentally be caused by some buggy code on another processor core on the device. If I change the alpha blending value of the video pipeline reserved for the rear view camera, you can see that the camera video becomes more faint. When this happens, our Jacinto 6-based rear view camera solution detects the change and displays a different warning message. In a real system, we will have a correction routine to update all the display controller register values back to what they should be to ensure that the rearview camera video is always visible when it needs to be. Finally, I would like to show you how our rearview camera solution withstands a complete crash of the infotainment operating system. I can force a crash of the kernel underlying the Android OS like this. You can now see that I no longer get any updates of the Android Live wallpaper layer that was showing the bubbles moving back and forth here. I can no longer manipulate the Android UI either. However, the rearview camera video is still updating on the screen. Also, I can still remove the camera cable, and the code on the auxiliary ARM Cortex-M4 cores continues to detect frozen frames from the camera as usual. This test illustrates the high level of robustness of this solution. In summary, TI's rear view camera solution on the Jacinto 6 processor family is a highly robust implementation of a rear view video system that is integrated within the infotainment processor itself. It handles many different fault conditions that can potentially occur in an infotainment system. It even withstands a complete crash of the infotainment operating system. For more information on TI's Jacinto 6 family of infotainment processors, please visit ti.com/Jacinto.